In this problem, we're talking about two different types of food, brand A and brand B, and we're comparing them because of the amount of protein and fat that they each have in them. So the first thing that I want to do is define my variables, and my variables are going to represent my two different types of food that we're feeding to the horses, or that Lori is feeding to the horses. So I'm going to let X equal the units of brand A food, and Y is going to equal the units of brand B food. For my constraints, we have those two that are kind of our automatics. You can't have a negative unit of food. And then as far as the other two constraints go, it's a little bit tricky for this problem. We're talking about protein and fat, but instead of writing everything about protein in one sentence and everything about fat in one sentence, they're kind of all jumbled together. So what I'm going to do is go through and highlight all of the numbers that are about protein in one color and all of the numbers that are about fat in another color, so we can visually see which numbers should go together. All right, so it says each serving is required to have at least 180 grams of protein. So I highlighted my protein number, and then 70 grams of fat. So I'm doing that in a different color. It says brand A has 15 grams of protein, so that's yellow, and 10 grams of fat, that's blue. And then it tells me that brand B has 20 grams of protein, so that's a yellow, and then 5 grams of fat, so again, that's blue. So all the numbers that are in yellow are going to go into a constraint together, and all the numbers that I highlighted in blue are going to go into a constraint together. So let's look at the protein one first. It says that a serving is required to have 180 total grams of protein. So 180 is going to be the number that's on the right side of my inequality. 15 grams of protein is how much brand A has. So I'm going to multiply 15 times my variable for brand A, which is X. And then I'm going to add to it 20 times my variable for brand B, which is Y. And then it says I need at least 180 grams. So at least means 180 or more. So that means greater than or equal to. Now we're going to do the same thing with the fat numbers. So again, 70 is my total, so that goes on the right side of my inequality. And then my other two numbers are 10 grams, that goes with brand A, and then 5 grams goes with brand B. And again, I need at least 70 grams of fat, so that would be greater than or equal to. All right, so I've got my constraints. Now I need my objective function. This one is different than the previous U-try. In the past, we've been trying to maximize things. Now we're actually going to be minimizing the cost. So it tells us here how much each unit of food costs for each different brand. So that's going to be what is used, those numbers are going to be used for my objective function. So instead of using P for profit, I'm going to use C for cost. And it tells me that brand A costs 90 cents per unit, so that's 0.90 times X, and then I'm going to add that to 0.60 times Y because it says 60 cents per unit for brand B. All right, next thing we need to do here is look into rearranging some of these inequalities. So I'm going to do the one that I highlighted in yellow. I'm actually going to do the work in orange so that when I graph you can see which one is which. So I'm going to rewrite 15x plus 20y is greater than or equal to 180. I need to get y by itself, so I'm going to subtract x from both sides. And I get 20y is greater than or equal to negative 15x plus 180. Then I have to divide everything by 20. So I have y is greater than or equal to negative 15 over 20. It doesn't reduce like to a whole number or to, 1/2 or anything, but it does reduce. I can divide both of those numbers by 5, so it would reduce to negative 3 over 4. And then 180 divided by 20 is 9. So that's going to be my first inequality that I graph in orange. And then I'll go ahead and do the other one now, and I'm going to do that one in green. So the other one is 10x plus 5y is greater than or equal to 70. So I'm going to subtract 10x from both sides, leaving me with 5y is greater than or equal to negative 10x plus 70. And then I have to divide everything by 5. So my other inequality is going to be y is greater than or equal to negative 2x, because negative 10 divided by 5 is negative 2. And then 70 divided by 5 is 14. So that's my other inequality. Now the two inequalities, those like automatic ones with zeros, I'm not going to draw those in. All that's telling me is that we're limited to quadrant 1. So I don't really need to draw them in. Really what I need to see is where these other two inequalities cross each other. So I'm going to do the orange one first. My y-intercept is 9, so that's right here between 8 and 10. And then my slope is -3/4. So I'm going to go down 3 and then right 4. And I'm going to keep doing that until I hit the x-axis, which would be right here. All right, so I have a solid line. Oops. So I'm going to connect these with a solid line. And then for my shading, this is greater than. So I want everything above the line. So that would be all of this up here. So this looks a little different than the ones that we've done where we're trying to maximize profit. Instead of like being contained kind of in the corner, now it's everything out above. All right, and then the last thing I need to do is my green line. So that would be this one down here. So my y-intercept is 14, so here's my y-intercept. And then my slope is -2, and I could make it over 1, so you can see the rise and the run. So I'm going to go down to right 1, and I'm just going to keep making dots. And I'm going to make this one really big because that's where the two lines cross. So that's going to be important for me to find the critical points. Okay, so that is where it finally hits the x-axis, and I'm connecting it with a solid line. All right, so I have to graph shade everything above this line again because it's greater than. So that would be all of this area up here. So all of this stuff that's highlighted in green is where they overlap. So now I really need to focus on my critical points. That's where my lines cross each other. And I actually only have 3 of them. My first critical point is going to be here. My second one is here, and then my third one is here. And you can't see that point anymore. It disappeared. So I only have 3 critical points. And those critical points are 0, 14. That one in the middle is 4, 6. And then on the x-axis, it's 12, 0. So now I'm going to take those 3 critical points and I'm going to plug them into my objective function, which is highlighted in green. And we'll see which one gives us the smallest answer, since now we're trying to minimize cost. We're looking for the smallest number. All right, so if I did 0, 14 as my point, I would be multiplying 0.90 times 0 and 0.60 times 14. And that answer would be 8.4. And because we're talking about money, I'm just going to add an extra 0 on the end, so it looks like 840. Now if we do 4, 6, so that's 0.90 times 4 and 0.60 times 6. That gives us 7.2, and I'm again going to add the 0 on the end, so it looks like $7.20. And then finally, 12, 0. So I'm plugging in 12 for x and 0 for y. That gives us 10.8, but I'm going to add the extra 0, so it's 1080. So I'm looking for the smallest one, and that would be this middle one here. So what this tells me is that my final answer is that I would want to use 4 units of brand A and 6 units of brand B food.